So we have learned today Wolff's reaction, or we can say intermolecular Wolff's reaction, the stoichiochemistry of metal catalyzed hydrogenation of alkenes, and the free radical halogenation and selectivity of the free radical halogenation. Welcome back to our fourth class, and we will step into the reaction chemistry with this class, and we will start off with alkanes. Now in case of alkanes do not react much. They are basically kind of inert compounds, but there are one type of particular reactions which alkanes always takes part, and those are free radical substitutions. That means hydrogen from alkane replaces specially by a halogen. These reactions takes part in a free radical pathway, and this is the prime area of focus in case of JEE-Mains or in case of NEET. So we will keep our focus on this part today. Now if we come to the first question, it says what will happen in this case. Now this is just a intramolecular Wolff's reaction. What happens in a Wolff's reaction when a Rx reacts in presence of sodium with another molecule of Rx, the alkyl pairs gets connected. How this happens basically, the sodium first loses an electron, then the alkyl gets dissociated like that, R plus plus X minus, and this electron attacks the alkyl to form a radical, and the sodium takes the halogen away. Now two molecules of sodium reacts with two molecules of alkyl halide to produce two molecules of R dot, and they react with each other to form a new alkane. So this is how reactions occur. Now if we come back to this problem, what will happen? This group, there is two halogen in one single compound, so this chlorine will go away, this bromine will also go away, and in presence of two sodium, this carbon and this carbon will form radicals. So it will form radical here, and it will form a radical here, and these two radicals will connect with each other to form this compound. So the option B will be our answer. So this is how Wolff's reaction or intramolecular Wolff's reaction occurs in this case of compounds. Though it will be not be stable much because there will be a tremendous angle strain in the compound, but still it will be a major compound. Now let's see our next problem. Now this problem is from the formation of alkanes. When we use metal catalyzed hydration or hydrogenation on alkene, they are always syn addition. That means the hydrogen adds from same side. So if we draw the structure like that, the solid portion has the D and the dotted portion has the CH2 CH3 group. Now the carbon double bond C, as the D is in the same position, that is the D will be on the same side, there will be a CH3. So if we add a hydrogen can either add, both the hydrogen can add from this side, or the hydrogen can add from this side. So if this side hydrogenation occurs, Or if from this side hydrogenation occurs, we will get two different compounds. So what will be the compounds? We will draw two structure. If hydrogen attacks from this side, the D and the groups will shift a little bit towards that side. So we can draw like D in this side, C2H5 on above, hydrogen from this side, similar case for this one, and CH3. And if we attack hydrogen from that is the left side, the structure will somehow look like this. So basically they are mirror images but not superimposable due to these two groups. They will not be mirrored, superimposable due to presence of one ethyl and one methyl group. So non-superimposable mirror images, as we have already learned in our previous class, non-superimposable mirror images are enantiomers, and they will form a 50-50 mixture, and a 50-50 mixture of enantiomers are called racemic mixture. So the answer will be racemic mixture, that is a racemic mixture will form. And what will be the compounds? The compounds will be like this. So this is how we solve the problem of this type easily. Now it is time for the next problem. Now it is our third problem, and it is a very basic problem. Just say asked at which of these steps, there are 5 options, which of these steps are the chain propagation step of a free radical halogenation or chlorination. So to answer this question, we just need to know the steps of the reaction. So there are 3 steps. One is the initiation step, the second is the chain propagation step, and the third is the termination step. So the reaction starts with the chlorine molecule breaking down to form 2 chlorine radical. So this is the initiation step. Now we come to the propagation step, and this is actually what the questions wants us. So the propagation step, what happens? The CH3H, that is the methane, reacts with the chlorine. How? The hydrogen reacts or adds to the chlorine, and we get a CH3 dot plus a ICl. Now this CH3 dot basically reacts with another chlorine, and it forms CH3Cl like that, and another chlorine is removed. So CH3Cl plus chlorine dot. And what happens in the chain termination? In termination, the 2 chlorine connects with each other again to form the chlorine molecule. There may be the excess of CH3 radical or methyl radical, so they react with each other to form a ethane, or this CH3 dot radical reacts with a chlorine dot radical to form CH3Cl. Now why these are a termination process? Because the radicals, if a step continues to generate radicals, like here in this case, this will be a propagation step. And if 2 radicals are joined with each other, or they are connected each other in any reactions, they will be form the termination step. So this is the propagation step, and it involves the formation of CH3 radical and the CH3Cl and a chlorine radical. So in this case, this is not the reaction. So 1 is not obviously in the propagation step. 2 is not also the propagation step, because there is no such reaction in propagation step. But in 3, this CH3 radical and its cell formation is the propagation step. So yes, 3 is the one correct answer. 4 is also not the propagation step, and also 5 is the propagation step. So 3 and 5 is the right answer. So our correct answer will be option C. So this is the problem, and how we will solve it this way. In the next question, it is also a very basic one. It said that how many monobromo derivatives will be formed. Now, bromine reacts with hydrogen, and if there are different type of hydrogen or non-equivalent hydrogen, the bromine will react with all the non-equivalent hydrogen to some extent. So we just have to find out how many different hydrogen is in the compound, and answer will be that easy. So now this CH3 is one of a kind hydrogen. So this is the hydrogen number 1. This is a 3-degree hydrogen. So this is hydrogen number 2. This and this are the same. So these are the number 3 types of third type of hydrogen. This and this is the 4th type of hydrogen, and this box is the 5th type of hydrogen. So it is very clear that there are 5 types of hydrogen in this compound. So the possible monobromo derivatives are 5. But we have to remember that the bromine is very selective, and it preferably reacts with a 3-degree hydrogen, because now this is a 3-degree hydrogen, and if it is removed, then this forms a 3-degree radical, which is very stable. So bromine preferably reacts with a 3-degree radical. So if it was asked that with which one of these 5 monomer derivatives will be the major product, so this will be the major product where the bromine replaces the 3-degree hydrogen. Okay, this was some extra information, but our answer is option B here, as there will be 5 monobromo derivatives. Now the last problem is the problem that we have already discussed, that bromine will abstract which of the hydrogen most readily. We have already known that the bromine will react with a 3-degree hydrogen. So here between HA, HB, HD and HC, only HA is the 3-degree hydrogen. So bromine will selectively react with this one. So A will be our answer. It is very easy. So we have already learnt how radical mechanism works, or how normal reactions work. So it's time for a quick recapitulation of what we have learned today. So we have learned today Wurtz reaction, or we can say intermolecular Wurtz reaction, the stoichiochemistry of metal catalyzed hydrogenation of alkenes, and the free radical halogenation and selectivity of the free radical halogenation. So these are our takeaways from today's reaction. So I hope you liked the video. So please like and comment in the video's comment section, and please subscribe to the video, and all the best for the examination. Thank you.